Sup y'all, and welcome to Accelerating Global Change and Realignments, Unit 6, Part 13. In this video, we're going to be looking at humans and the modern environment.
For everyone else who's here, let's get down to brass tacks.
Aside from natural phenomena, humans are causing unprecedented environmental stress. As the ecumene and total population expands, there continues to be negative impacts on the ecosystem. Through deforestation, soil salinization due to improper irrigation techniques, overfishing, soil contamination due to the introduction of a plethora of chemicals, desertification intensified through overgrazing, as well as other human-induced impacts. The 1960s was the first decade in which the United Nations and the international community began to enact major initiatives to protect the environment. Malaria is one of the big global killers, causing over 1 million deaths annually, with mosquitoes as the vectors crossing over international lines. In 1946, Ceylon, now known as Sri Lanka, had almost 3 million cases of malaria and more than 12,500 deaths before the use of DDT, a pesticide that kills mosquitoes. By 1963, after a large-scale spraying campaign, the number of cases fell to 17, and the number of deaths fell to 1. However, a year earlier, Rachel Carson, who almost single-handedly started the environmental movement, wrote Silent Spring, blaming DDT for a myriad of issues, saying it was carcinogenic, or cancer-causing, to animals and to humans, and that it was to blame for the thinning of eggshells in birds such as eagles. With no bird singing, you would have a silent spring. Sri Lanka, along with a host of other countries, outlawed the use of DDT. In 1969, 5 years after Sri Lanka stopped spraying DDT, the number of deaths had climbed to 113 and the number of cases to 500,000. Malaria rates soared in other countries that stopped spraying DDT as well. The U.S. Environmental Protection Agency, or EPA, held scientific hearings on the use of DDT in 1972, and determined that DDT could not be proven to have all the deleterious effects claimed against it, but the ban went into full effect regardless. So is DDT a toxin or tonic? It pretty much boils down to which side you agree with. Nonetheless, many countries have resumed using it for years, whereas other countries, like Sri Lanka, have used methods like indoor residual spraying and bed nets to prevent the transmission of malaria, often with great success. In fact, in 2016, the World Health Organization declared Sri Lanka malaria-free once again, albeit half a century after the feat had been previously attained. This is just one example to illustrate how any issue is multifaceted, and simple solutions are often hard to find. Let's take a look at water, a renewable resource, meaning that given enough time, it will replace itself through natural causes. In many areas of the world, people have congregated in places where water supplies are insufficient. For example, Israel is a country with around 6 million people, but they consume 3 times as much water as Jordan, the West Bank, Gaza, and the Palestinians combined, a population of around 7 million. And the proposed Palestine contains key fresh water sources for Israel. So this is a classic allocational boundary dispute. Aha! Aha! And you can see why forming Palestine is more complex than it looks on the surface. Now, worldwide, about 70% of all the world's water supply is used in agriculture, and another 20% is used for industries. And one of the great ecological disasters of the 20th century occurred in Kazakhstan and Uzbekistan, whose common boundary runs through the Aral Sea. Streams that fed this large body of water were diverted to irrigate the surrounding desert, mainly for commercial cotton production. Heavy use of chemical pesticide ruined the groundwater below, causing a health crisis that some observers describe as an ecological Chernobyl. In the meantime, the Aral Sea began to dry up, and by the mid-1990s, it had lost more than 3/4 of its total surface area. By 2014, it was revealed that the eastern basin of the Aral Sea had completely dried up, and is now called the Aralkum Desert. Another interesting story deals with the Great Pacific Garbage Patch, which is a gyre of marine debris in the central North Pacific Ocean, which extends over an indeterminate area, with estimates ranging very widely, with some suggesting it may be as large as the size of Texas. The patch is characterized by exceptionally high concentrations of plastics, chemical sludge, and other debris that have been trapped by the currents of the North Pacific Gyre. Despite its size and density, the patch is not visible from satellite photography, so you can't see it on Google Earth.
Wrong.
Trust me, I've tried. And there are also smaller, yet significant garbage patches in the North Atlantic and Indian Oceans as well.
And now for something completely the same. A man with 3 buttocks.
Moving on to the atmosphere, one thing that has been constant about the climate throughout history has been change. The greatest driver of this change has been the sun. During times of few sunspots and solar activity, the Earth has descended into long spans of cooler temperatures, such as the Little Ice Age, lasting from around 1350 to around 1850 CE. That said, as global populations expand and develop, our capacity to affect the environment has swelled to unprecedented levels. While there are some natural releases of chlorofluorocarbons, or CFCs, by the 1980s, by far most of these gases were released through anthropogenic means, meaning man-made. CFCs are compounds that were found in refrigerants, propellants, and aerosol cans. When combined with the ozone layer of O3 in our stratosphere, CFCs combine with the ozone, making heavier particles and fall back down to Earth. A so-called hole in the ozone layer was discovered over the pristine environment over Antarctica, and policies were enacted to almost completely eradicate CFCs from industrial and human use. And so the ozone, for the foreseeable future, is safe. In 1987, the Montreal Protocol was enacted. The phasing out of CFCs and other ozone-depleting substances has been very successful, and the virtual hole in the ozone over Antarctica has been slowly recovering. A greater current concern deals with anthropogenic greenhouse gases that can trap more heat within the atmosphere, such as carbon dioxide, methane, and nitrous oxide. And while we release millions of tons of these gases each year, most comes from natural causes, such as the decomposition of vegetation. The greatest greenhouse gas of all is water vapor, counting toward as much as 95% of the warming effect, of which humans have almost no impact. We also release a small fraction of the overall carbon dioxide as compared with natural causes, and the same goes for methane and nitrous oxide. That said, a large majority of the scientific community claim there is not only a correlation between the increased release of anthropogenic greenhouse gases and rising global temperatures, but that humans are the main cause for this change. Even bovine belching and flatulence is said to be a cause for climate change. That's right, cow burps and farts release methane, and with as many as 1.5 billion cows grazing across the planet, their impact is not going away anytime soon. One of the longest-standing international initiatives has dealt with reducing greenhouse gases, such as carbon dioxide and methane. In 1997, the Kyoto Protocol was enacted, limiting many developed countries in terms of carbon emissions. There were, however, limitations to the initiative. For instance, 100 developing nations, including NICs such as India and China, were exempted. In 2009, the Copenhagen Agreement endorsed the continuation of the Kyoto Protocol, even though it is not legally binding. Under the Obama administration, the US helped draft the agreement. Anthropogenic actions can lead to acid rain, which forms when sulfur dioxide and nitrogen oxides are released through the burning of fossil fuels. However, acid rain is also produced through volcanic eruptions. Pollutants combine with water vapor to form dilute solutions of sulfuric and nitric acid, and then are washed out through precipitation like rain, fog, or snow. Now, keep in mind, you're not going to be burned alive by acid rain, but it can be caustic enough to do great damage over time, such as the acidification of lakes, stunting of forests, loss of crops and fish, and even the disintegration of historic statues. Smog can occur where there are excess amounts of ozone in the troposphere, which is the part of the atmosphere between 0 and 16 kilometers up. Now, smog is tied to, not geography.
Yes, well!
It is caused by human releases of fossil fuels through car emissions and industrial activity. Today, the worst instances of smog occurs in cities within many of the newly industrialized countries, such as Thailand or China. Now let's look at the land, and as you can see on the map, more specifically, at the world's forests, which cover around 31% of all land area on the globe. This amounts to around 15 million square miles. Compare that to the pre-industrial number of around 22 square miles, and you get an idea of how mankind has altered the physical landscape. The forests, and especially the tropical forests in the low latitudes, are vital contributors to the oxygen cycle, converting carbon dioxide into breathable oxygen. Now, deforestation is not a singular process, and it has been going on for centuries. But some of the main causes go to subsistence farming, more specifically things like shifting cultivation, but also commercial agriculture, which primarily highlights the clearing of forests for the grazing of cattle and other livestock. But also logging and the use of fuel are some of the major reasons for deforestation. And the loss of potentially productive soil to erosion has been described as a quiet crisis of global proportions. Land degradation affects nearly 40% of the world's arable land. Remember, soil is a renewable resource because with proper care it can recover. However, it is being used as if it were a non-renewable resource. A study in 2006 reported that globally around 37,000 square miles of croplands are lost to soil erosion each year. As technology has improved, more efficient fuel sources have been needed, making certain regions more valuable and some previously valuable regions less so. The harvesting and use of wood as a primary energy source reached its peak in the middle of the 19th century and has declined ever since. Coal, as a total percentage of global energy use, reached its peak in the 1920s. The geopolitical goal of sea power reached its peak during this era as well. Colonies and possessions for coaling stations were strategically pursued by core states. Oil peaked around the mid-1980s when it represented around 50% of the global energy supply. Today, major industrial complexes are not confined to oil fields. They are fed through a huge system of pipelines and oil tankers on a global scale. Increasingly, natural gas has gained ground as a cheaper and somewhat more environmentally friendly alternative to oil. Many new reserves of natural gas have been accessed through fracking, the process of fracturing rock and shale under the ground through pressurized liquids to extract gas and sometimes even oil. Other sources are used, such as some nuclear energy, and also from biofuels such as ethanol, and even renewables such as geothermal, hydroelectric, solar, and wind. However, these are used to a much lesser degree. Even though these sources may be supposedly cleaner, they are not nearly as cheap or efficient as fossil fuels. Yet.
I fart in your general direction. Your mother was a hamster and your father smelt of elderberries.